Hello everyone, this is the third lecture on carbohydrates. In previous two lectures, we have discussed about monosaccharide, their structure and isomers. In this lecture, we will talk about the disaccharides. What are disaccharides? When two monosaccharide units join together with covalent linkage, they form disaccharide, and this process is called condensation. Since water is released during this process, this is also called as dehydration. And when disaccharide unit is hydrolyzed in presence of enzymes or mild acid, they form monosaccharides. Since water is used for lysis, this is called as hydrolysis process. Let's talk about few common disaccharides. First one is maltose. So when two alpha D glucose units join together with this glycosidic linkage, they form maltose. Alpha glucose means on first anomeric carbon, this OH is down the plane. So if you look at both the sugar, OH is down the plane on the anomeric carbon. So these two alpha D glucose are linking here. So actually the formation of disaccharide is formation of acetal. So reaction is based on the formation of acetal from hemiacetal. So in linear glucose, aldehyde group reacts with alcohol to form cyclic form of sugar, and this is called as hemiacetal. If you look at this first number carbon, which is anomeric carbon, it is attached with OH. So this is OH here, OR group. So this OR group is here, R group, this R group is here, and this H is here. So this is hemiacetal. Now when this hemiacetal react with this ROH, they form acetal. If you look here, this is R group, second R group, and this is OH. Now when these two sugar reacts, they form this acetal. If you look at this carbon now, hydrogen is present here, this OR is present here, this R is present here, and this newly formed OR is present here, and water is released in this process. So this water is released here. Now what happened, if you look at this, to formation of disaccharide, always at least one anomeric carbon is involved. If you look at this first number carbon, which is anomeric carbon, it is attached with oxygen from both the side, and oxygen is more electronegative, so it's pull the electrons from carbon toward itself. So carbon becomes electropositive and it is electron deficient. So it acts as electrophile and it can be now attacked by nucleophile. So here this OH act as nucleophile, it attack this at this carbon, and now water is released, OH from here and hydrogen from here. So water is released here, and now this oxygen bond with this carbon. So since this oxygen is involved in connecting these two sugar, this bond is also called as glycosidic linkage, and this linkage is formed between anomeric carbon, first anomeric carbon of this sugar, which is in alpha form. This is called as alpha 1 and 4. Here we are not mentioning alpha or beta because this carbon is not anomeric carbon. So this is maltose, and it is also called as alpha D glucopyranosyl 1,4-D glucopyranose, and in short it can be written as GLC, alpha 1,4 GLC. And if you look at the molecular formula, 2-glucose has molecular formula C6H12O6, and now since water is released here, it has now become C12H22, 2 hydrogen molecule is released, and O11, 1 oxygen is released here. Now what is the source of maltose? So maltose is present in germinating seeds like barley, rice, wheat and corn. So barley, rice, wheat and corn contain a starch, and during the germination process amylase enzyme get activated, which convert this starch to maltose. Next one is sucrose. Sucrose is formed when alpha D glucose and beta D fructose reacts together. If you look here, this is OH down the plane on anomeric carbon. In fructose, carbon number 2 is anomeric carbon, and here this OH is up the plane, so this is beta D fructose. This alpha D glucose and beta D fructose link together with alpha 1 beta 2 bond. So now this carbon is present here, second number, so fructose flips over and form this bond, and since first anomeric carbon is present at position 1 and it is in alpha form, this is alpha 1, and this anomeric carbon is present at second position and in beta form, this is called beta 2. So this is alpha 1 beta 2 bond formed between alpha D glucose and beta D fructose, and water, since these two are reacting, water is released here and sucrose is formed. This is also written as alpha D glucopyranosol, and because glucose is pyranose structure, and fructofuranocide because fructose is in its furanose form. In short, it can be written like this. If you look here, we have talked about the mutarotation, in which we have talked that in aqueous solution, sugar always interconvert between its open and cyclic form. But if you look here, sugar always opened at their anomeric carbon, and here both, in case of sucrose, both the sugars have their anomeric carbon engaged in bonding. So sucrose cannot be converted to its open form because the anomeric carbon is engaged in bonding. Sucrose is most abundant disaccharide and it's formed by plants, and we called it it's common table sugar, and it is obtained from the sugar cane. Its formula is also C12H22O11. All sugars are divided into two groups, either they are reducing or non-reducing. So they are always, we say, reducing or non-reducing in their open structure form, because in open form, if they have aldehyde group, this aldehyde group act as reducing agent. Reducing means it's reducing some group and oxidizing itself. So here this aldehyde group, in alkaline solution, this aldehyde group reduce this cupric ion to this cuprous ion, and now this sugar, this glucose has oxidized to D-gluconate. So this aldehyde is oxidized to carboxylate ion. It's carboxyl group actually, but in alkaline solution, since hydrogen is in less amount, it donate its proton, so it has now become D-gluconate ion, and this oxidized cuprous ion form red cuprous oxide in alkaline solution. And by measuring the amount of this precipitate, we can measure the concentration of sugar, like for example concentration of glucose in urine or blood sample of a diabetic person. So this is the use of reducing sugar to test the amount of sugar. We will talk in detail about this in coming lecture. Next is tautomerization. So if you look at fructose, it has a ketone group. So ketone ideally does not act as reducing agent, but it gives the reducing sugar test positive, because fructose get converted to aldehyde group through the process of tautomerization. What is tautomerization? It is the reversible chemical process where a compound shifts between two structural forms by moving a hydrogen atom or double bond. If you look here, here in fructose ketone is present. It get converted to this anadiol intermediate, means this bond in shifting, double bond was here, now it's shifted here, and these two carbon, both of these carbon are attached with this hydroxyl group, and this condition is called anadiol. Now this anediol is converted to either D-glucose or D-mannose, and both of these have aldehyde group. And now this aldehyde actually act as reducing agent. So fructose itself is not reducing sugar because it has ketone group, but in alkaline solution it get converted to either D-glucose or D-mannose, and that's why it behaves as reducing sugar. Next, one more term you need to know about is inverse sugar. So what is inverse sugar? Normal sucrose solution rotate the plane polarized light in right direction, means it is dextrorotatory, and this sucrose solution rotate the plane polarized light toward right direction with plus 66.5 degree. And when you hydrolyze this sucrose in presence of mild acid or enzyme, it breaks into glucose and fructose. So glucose is dextrorotatory. It rotates the plane polarized light toward right with plus 52.5 degree, whereas fructose is levorotatory and it rotates this plane polarized light toward left direction with minus 92 degree. So now since fructose is rotating more, net rotation becomes negative and it is minus 19.7 degree. So since the rotation, initially this rotation was in right direction, means sucrose solution was dextrorotatory. Now it has become the levorotatory. So since it's inverting the properties of this sugar from dextrorotatory to levorotatory, now this is called as inverse sugar. So why this is important? Because now in this solution fructose is present and fructose is more sweeter. It is sweetest natural sugar, so it enhances the sweetness. It also prevents the crystallization. We know about the table sugar, it is in crystal form, but this inverse sugar prevent the crystallization. So it, because it's preventing crystallization, it gives a smooth texture to jams, jellies and candies. Next disaccharide is lactose. Lactose is formed when beta D-galactose and beta D-glucose join together with beta 1,4 linkase. They form lactose. If you look here, this is beta form of galactose. Here anomeric carb, on this anomeric OH is upside, this react with this beta D glucose. Here also OH is upside. In this first number anomeric carbon is involved in bonding, so this is beta 1 and this is fourth number sugar. So this linkage is beta 1,4 linkage. Lactose is naturally present in milk and it can be digested by lactase enzyme, and you must have heard the term lactose intolerance. So many adults lack this enzyme lactase, or they have very less amount of this enzyme. So when we this kind of person drink the milk, this lactose will move through the small intestine and it will not get digested, and since it is not getting digested, it will not be absorbed in the blood stream, and it will move to intestine, and because of osmotic effect it will draw water in the gut. And also when it this lactose will move through the large intestine, it will be digested by colon bacteria and produce different gases, and because of that it causes bloating and diarrhea, and this condition is called as lactose intolerance. Next one is trehalose. It is made between alpha D glucose and alpha D glucose. When these two reacts together, they form trehalose. So here linkage is between both the anomeric carbon and both the sugar are alpha D glucose. So this bonding is alpha 1 linkage. Here you can also see that since both of these carbon are anomeric carbon and these are engaged in this bonding, it cannot be opened up and it cannot work as reducing agent, because we already discussed that free aldehyde group is necessary to become an reducing sugar. So trehalose also behave as non-reducing sugar. It is present in circulating fluid of insects. That was all about disaccharide. Thanks for watching. See you in the next video. In next video, we will discuss about the different taste for carbohydrates.